and say, do you want to check on your cat?
Yeah. She's like, oh no.
Yeah, I mean, poor kitty cat. All right, so we're live and we've started the webinar. We're going to let our participants come in. Hi, everyone. Hello, hello. We wanted to let you guys know that Miss Elsie is going to be really interactive. And so if you've done some of these with us, we've activated the chat. And so when she asks you questions, we'd like you to put those questions, or the answers to your questions in the chat, or probably best in the chat, but you can also use the Q&A feature, and we will relay all that information to her. I want to thank you so much for being here today. And you're new, you're the first time to the teach-in, so I hope you love it, and I hope you'll join us again next year. And so with that, I'm going to turn it over to you, Miss Elsie.
Awesome. All right, so are we ready to jump in? All right, perfect. So then I'll introduce myself. So hello, everyone. My name is Ranger Elsie, and I am so excited to be talking to you all today. And I'm coming to you live from the one, the only Zion National Park. So I'm lucky enough that this is what it looks like right outside of my office window. Now, just like your teacher, their teachers in your classroom, I'm also a teacher. But Zion National Park is usually my classroom. So I have a few rules I'd like us to follow throughout our time together. And I think that keeping everyone on mute is not going to be as much of an issue, but if that is something that you can control, then I would appreciate if you could stay on mute because, you know, we're all connecting from home, which is fantastic, but there could be a lot of noise going on in the background. There might be a dog barking, a really loud truck might be going by. So just to make sure that everyone is able to hear me, I'd appreciate if you could stay on mute. Now, that doesn't mean I don't want to hear your thoughts. And I do have some questions that I will be asking throughout our time together. So if you could use that handy dandy chat box over here, I would love to see what you're thinking about. Keep in mind though, I only need to see that answer one time. So if you get really, really excited, and what we're talking about today is really exciting, so I understand. But if you put that answer in there like 200 times, or just get so excited you can't even form words and start keyboard smashing, it's kind of like you're yelling at me, and it's really distracting and stops me seeing what other people are saying. So if you do have an answer for me, fantastic, but please put that in the chat box only once and keep it to answers. Last but not least, if you do have any questions that come up, something I say sparks your curiosity, keep that question tight in your head. Maybe write it down if you think you'll forget. I promise at the end, I'll answer as many questions as I can. All right, so let's jump in. So I am talking to you all the way from over here, this red star in southwestern Utah. That's where Zion National Park is. And while Zion National Park, at least in my opinion, is the best national park in the entire country, it's not the only one. There are actually over 400 different national park sites across the United States. Some of them you might have heard of before, maybe like Yellowstone, which was the very first national park in the entire world. Up in Alaska, we have national park sites that are millions of acres of wilderness. And over here on the East Coast, we have national park sites that might just be the size of someone's old house, but tell a really important story about American history. We have national seashores, national recreation areas, national monuments, pretty much anything you might be interested in, we have a national park site for you. They're all incredible places to explore with your friends and your family. And even though all of these places look really different, you'll know you're visiting a national park site because you will see this symbol right here. Now, this is the badge of the National Park Service. It's kind of like our mascot, kind of like our bat symbol. But the best thing about it is that it actually gives you clues to everything that rangers like myself are protecting, preserving, and educating our visitors about. So let's see what we can find in this badge. Well, the first thing that pops out at me is this bison right here. And that represents all of the animals, all of the wildlife in our national park site. We have the giant sequoia tree right here, which represents all of the plants that grow on our park sites. We have this lake hiding over here, which doesn't only symbolize the clean water, but also all the recreation, all of the fun that you can have while visiting the national park site. Because who doesn't have fun while visiting the national park? We have this mountain in the background representing all of the landscapes, all of the beautiful scenery. And the last thing, I actually think is pretty tricky, but that is the entire shape of our badge, which is what we call an arrowhead. And that arrowhead, it represents the layers and layers and layers of history found in every single one of our park sites. America is a really old place, and there are lots and lots of stories to tell. Now, here in Zion, we don't have bison. We definitely do not have giant sequoia trees, but we have lots of other plants and animals that we love very dearly. Just like the California condor. Now you might be thinking like, oh, that is not the cutest bird that I have seen. And you might be right. But while this bird might not be too adorable, it is fantastically special to us here in Zion National Park. At one point, not too long ago, there were only 22 California condors left in the entire world. Think about how many people are in your class. Maybe around 22, maybe more. Now imagine if those were the only humans left on the entire planet. Ooh. Thanks to a conservation effort and scientists, though, these birds were brought back from the brink of extinction, and now there are a few hundred flying around. And we're really lucky that a few call Zion home. And while you're exploring our park, you'll know that there's a California condor flying above you, because it might feel like there's a small plane soaring above you. These are huge birds. Now, from wingtip to wingtip, this bird is about 9.5 feet long. So if you tipped it on its side, it would be taller than the tallest person on Earth. But it's not just animals we have. We have some pretty amazing plants as well, mostly of the spiky variety. We have our yucca right here, and of course our prickly pear cactus. And yes, it is in the shape of a heart, because we heart our prickly pear here in Zion. Now we are a desert, and so all the plants that live here have to be fantastic at conserving or saving water, as well as protecting themselves from any critter that might come by and think that they look like a tasty snack. Even though we are a desert, we're fortunate to have the Virgin River flow year-round straight through our canyon, and it provides a really important source of water for both the plants and the animals that live here, and provides an opportunity for a whole lot of fun. Now, this is a picture of the Narrows, which is one of the most famous hikes here in Zion National Park. While it's really hot here in the summer, visitors will actually walk upstream in our river to a place where the canyon gets so small, you can almost touch either side with your hands. And people are coming from all over the country and all over the world to ooh and ah over our beautiful landscapes, our incredible cliffs. We're really famous here in Zion for our geology, which is what we're going to be talking about today. So when I say the word geology, what does it make you think of? When I say we're going to be learning about geology today, what comes to mind? In that chat box, if you could please tell me, what do you think geology means? What do you think of when you hear that word? Geology. Ooh, I'm getting the study of rocks and minerals, all of the land. Studying the earth? Yeah, science, excellent. Earth's physical structure, ooh, all of the earth, all of it. Science, yeah. Oh my gosh, landforms. Study of Earth's surface, wow, studying environment. Oh my gosh, I'm getting some fantastic answers here. History or evolution or land, nice. Wow, yeah, these are all really, really great things to think about when you hear the word geology. And we can actually split this word into two parts. On one side, we have geo, meaning earth. And on the other side, we have logi, which means the study of. So when we smash these two halves back together, we get the study of the earth. And that means a whole lot of things, and a lot of what you mentioned over here in the chat box. The earth means landforms, it means rocks, it means minerals, it means Earth's surface, it means, yeah, in the environment in a lot of ways. Pretty much anything that's happening underneath your feet, that's geology. And while we are famous for our geology here in Zion, we're really famous for our rocks, and one type of rock in particular, sedimentary rocks. Now here in Zion, we're pretty much completely made up of sedimentary rocks. Any rock you pick up, probably going to be a sedimentary rock, which is a fancy way to say it's a rock made up of a lot of other tiny rocks, sediments, broken down little pieces of other rock. And these sediments, they can be different sizes, shapes, textures, colors, as big as gravel, and as smooth and as fine as clay or mud. Now, sedimentary rocks are usually named after the sediments that they're comprised of or made up of. So here in Zion, we have a lot of sandstone. What kind of sediment do you think sandstone is made of? In that chat box, tell me what kind of sediment you think sandstone is made of. Excellent. Yep, it's in the name. Sand, you're all completely right. I couldn't fool you. So all of these little sediments are coming together to form our sedimentary rocks. And you can have those different kinds of sedimentary rock. Every single layer that you see in the cliffs of Zion is a different kind of sedimentary rock made of the sediments that were lying around on the surface of Earth at that time that rock was formed. All right, my friends, I will be asking you questions throughout the presentation, and I have reached my first question, which is Zion National Park has blank rocks, meaning they were formed by the gathering of smaller pieces of rock like sand, silt, or mud. What kind of rocks does Zion National Park have? Oh my gosh, I'm getting so many amazing answers in that chat box. And you're all 110% right. Zion National Park has sedimentary rocks, meaning they were formed by the gathering of those smaller pieces of rock, those sediments, like sand, silt, or mud. So together today, we are going to be exploring the sedimentary rock cycle and learning how Zion Canyon was formed. And we can break all of this down into 4 steps. And I have some hand movements I'd like us to do together to help us remember each one of those 4 steps. So the first one is deposition. So I'd like you all to pick up your sediment and put it down, deposit it. On your bed, your table, your desk, just pick up your sediment and pop it down. Awesome. So second step is lithification, which is a scientific way to say glue or bind together. And so for lithification, I'd like to see you give a big clap on 3. Ready? 1, 2, 3. Lithification. Awesome. Now the party really gets started when we get to our third step, which is uplift. So I think we gotta raise the roof a little bit. Can I see your best roof raising? Just gotta lift up that roof. Awesome. And then our 4th step and final step is weathering and erosion. So we gotta get down and we gotta break down. So I'd like to see you just kind of bump your fists together. And you can put as much shoulder and head action in there as you want. Excellent. All right, so to begin our geologic journey, we have to start at the beginning with deposition, which is the process of adding sediment to the earth, right? We're picking up our sediment and we are laying it down. We have to deposit our sediment to start building up our layers. Put down your sediment in order to build it up. So each one of these layers that you can see in our cliffs, they were formed during a different deposition event. And geologists, they're kind of like rock detectives trying to solve the mystery of Earth's history. And they look at what was deposited at each one of these layers to try to figure out what Earth looked like at that time that layer was formed. So let's be like geologists and go back in time and see what Zion used to look like hundreds of millions of years ago. We're going to start at one of our lowest and oldest layers, which is Chile. So let's hop in our time machine, zoom back in time until we're just about 225 million years in the past. Not too long ago. And Zion does not look like it does in those pictures that I showed you of it today. Instead, the desert is more like a swamp. Geologists think that at this time, this area was covered with water and lush green vegetation. It's probably pretty hot and muggy. So if you've ever been to Florida or you've seen pictures of Florida, think Florida, but instead of alligators we have running around, we have dinosaurs. Now these critters were enjoying all of this plant life, all of these trees, all of this water, but in the background, volcanoes were exploding. And all of that ash was deposited and covering the earth. And it's because of that ash. When you explore the channel layer today, you see these beautiful sherbety layers and these colors, as well as this kind of popcorny, crumbly texture. Now, this layer, this sediment that was deposited, turns into the most incredible mud when we get any sort of rain or snow. I know rangers who have hiked in the Chile layer after it's just rained, and they still have mud on their hiking boots from 10 years ago. But it's not just mud that you'll find in the Chile layer. You'll also find interesting fossils like these. And I actually have one with me today. So while you are walking around the Chile layer, you might find something that looks a little like this. Now this fossil has been polished, so it's not exactly what you would see, but it might actually remind you of something that you can see outside today. Maybe even you're outside your window right now or in a park near you. Does it remind you of anything that you can see in the world today? A shell, maybe? Tree bark, yeah. Rocks? Part of a log, maybe? A tree stump, yes. These are all excellent guesses. So this is a fossil that we call petrified wood. And it used to be a tree that was alive about 225 million years ago. So at some point this tree, it fell over and a lot of ash and mud and different sediments were deposited on top of it. And that tree literally became stone. And so it's all of the petrified wood that you can find in the Chile layer that geologists have used as clues to piece together that there used to be a forest where there's a desert today. All right, my friends, let's move up a layer until we are now in the Kayenta, just a wee 200 million years ago. And this red star is where Zion is. So that really lush, green, swampy environment, it's starting to dry out. Geologists think that the Kayenta was probably similar to what the Nile River is like today. You see this green ribbon, which is water and a lot of plant life, but surrounding it, it's really drying out. Much more dry, much more sandy. But if we were on at eye level during the Kayenta period, we would see something like this. So instead of Zion National Park, it's more like Jurassic Park at this time. This is the time of the dinosaurs. There were lots of these critters running around having a grand time. There was a large lake that covered this area called Lake Dixie, and the shores of that lake were the perfect sediment to preserve fossils. Things like dinosaur footprints, dinosaur bones, even dinosaur skin prints. For one of these critters decided it was a little bit tired and lay down in the mud to take a nap, and we can find an imprint of its scales millions of years later. All right, now we have to talk about the big one, our Navajo sandstone. And this is the layer that takes up most of the 4,000-foot cliffs that you'll see in Zion today. And so to create such a huge layer of sandstone, we need a huge amount of sand, and that we had. During this time, geologists think that Zion was part of the largest sand dune desert in the history of the world. Again, this red star is where Zion is, and what are we surrounded by? Sand, 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 mud, sand, mud, sand, 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 sand. Sand dunes as far as the eye can see, hundreds of feet tall. Now, unlike in the Kayenta layer, we don't get very many fossils from this time. Sand is not a great sediment to preserve things like footprints or bones. If you walked on a beach in the dry sand, sometimes your footprints aren't there, even just 5 minutes later, let alone hundreds of millions of years. But we do get a different kind of fossil. Something that looks like this. This is what we call cross-bedding, and these are petrified wind patterns. So when that wind was blowing through the desert, moving all of that sand, some of those wind patterns were frozen in time. So we can figure out what the weather was like 190 million years ago. Now, each one of these layers here in Zion that you can see, it's a different snapshot of the Earth from the past. And geologists use that to piece together what the Earth looked like at that time, looking at the clues from what was deposited in each layer to paint a picture of Zion stretching back hundreds of millions of years. All right, my friends, this brings me to question number 2, which is, can you please find the word that means the process where sediment is added to the land? Is it lithification, sandstone, deposition, paleontology, ancient landscape, or perhaps gravel? Which one of these words means the process where sediment is added to the land? Oh my gosh, these answers are pouring in. I'll give you a few more seconds. Which one of these words? And exactly right. So deposition is the process of adding that sediment to the land. We are laying down our sediment in order to start building up our cliffs. But we don't have our cliffs yet. We have just laid down all of our sediment, but it's still those little pieces of rock and sand and mud. We don't have these huge, huge rocks that you see here today. In order to get to our cliffs, we need to move to our next step, which is lithification, turning sediment into a rock. So that is a fancy word for glue together, bind together. I'd love to see you give your big lithification clap again. Ready? 1, 2, 3. Lithification. Awesome. So we need a certain recipe in order to make a rock. And lucky for you, I am an incredible rock chef. So welcome to my cooking show, How to Make a Rock, with your lovely Zion Ranger, yours truly. So I have all of my ingredients that I need with me here today to make a sedimentary rock. So let's see what I have. Seeing as we are here in Zion, I think that it's only appropriate to make a piece of sandstone. So the sediment that I have with me here today is sand. This is just a lot of dry sand. I think that I need something to kind of make it a little bit more goopy. So I have my water, which I did gather straight from the Virgin River, so it's locally sourced, organic. So I'm just gonna add some water. You know what? I think that looks about good. All right, so now I just kind of have this like wet sand sitting in my bowl. I think I might use something else to kind of squish it together, right? I think that I just need to add some pressure. And lucky for you all, not only am I an incredible rock chef, I'm also incredibly strong. I practice making rocks every single day. So with my incredible mega muscles, I am going to squeeze this wet sediment for about 5 seconds. And let's see if I end up with a piece of sandstone like this. All right. Are you ready? Here we go. 1, 2, 3, 4, and 5. Whew. All right. So in that chat box, my friends, can you tell me whether you think that when I open my fist, I have yes, a new piece of sandstone, or no, Ranger Elsie, what are you talking about? So yes or no, do I have a new piece of sandstone in my fist? Ooh, I'm getting some yeses, I'm getting some nos. I'm getting a lot of just yes, no's, so it seems like we're kind of 50-50 split right now. All right, so let's see. I appreciate everyone who said yes, in that your faith in my incredible strength. But when I open my hand, ooh, I definitely made a mess, but that was not a piece of sandstone. I feel like I used all of the ingredients that were on my stand here, but maybe I'm missing one of those key ingredients. So I squeezed that rock for 5 seconds. Do you think that's enough time to make a new piece of sandstone? No, exactly. You are all right. I need more time. Now, it takes millions of years to be able to lithify sediment into a rock. And while you all seem like really lovely folks, I think we can all come up with a few better ways to spend the next million years than sitting here together watching me squeeze some sand in my hand. But really, it is that time, that is that last key ingredient that allows us to go from our sand into the sandstone that you see in our park today. All right, my friends, can you please remind me of that recipe one more time? And I promise I won't forget it this time. What are those 4 ingredients that we need in order to make a sedimentary rock? Awesome. Oh my gosh, you are all rock chefs too. This is fantastic. I'm getting some really great answers. I'll give you a few more seconds. What were those 4 things that we need? Those 4 ingredients that we need to make a rock. Awesome. And yep, you are all right. You know the recipe. We need sediment, pressure, water, and time. Those 4 things in order to form a new sedimentary rock. Oh my gosh. Like I said, you are all now rock iron chefs. Maybe later today, you can start standing there, put all these ingredients together, and wait for the next million years to form a new piece of sandstone. All right, so we just deposited our sediment. We lithified it into a rock, and now we have to uplift all of those rock layers with Uplift. Do you remember what we did for Uplift, right? We had to raise the roof a little bit, so I'd like to see you all do that again, right? Let's raise the roof. Whoop, 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 whoop. Right, we're gonna have a party with Uplift, but before we get too into that, we have to talk about plate tectonics. So the Earth is floating around on all of these different plates. We can kind of think of the Earth as a big cup of hot chocolate, right? It's winter time. There is nothing better than going from being cold outside to be able to drink a nice, tasty, warm cup of hot chocolate. And maybe you're feeling a little fancy. So you pour on some whipped cream, you spread some whipped cream on there. Those tectonic plates are kind of like that whipped cream, floating above this really, really hot liquid. Or in the Earth's case, That's our magma, our molten rock, which is underneath all of these plates. But our plates, unlike your whipped cream, it's not just sitting there. They are playing the most ginormous game of slow motion bumper cars. At these plate boundaries, they're smashing together, they're grinding past each other, and sometimes one will even slip underneath the other. And it's because of that subduction of one plate under the other, we get the Colorado Plateau, which Zion is sitting on. Now, there was so much pressure when one of these plates slipped under the other that it actually popped this ginormous piece of earth that covers part of 4 states high up into the air. Before Uplift, we were sitting at about sea level, 0 feet of elevation. And now the visitor center here in Zion, one of the lower points in our park, is at about 4,000 feet of elevation. Now, because of Uplift, this huge area of land was slowly lifted high up into the air. All right, my friends, that is a short, sweet, but very important section. So can you please tell me why Zion is no longer at sea level? What's that process called? Do you remember? Awesome. Oh my gosh. I have a lot of geologic geniuses in the chat box right now. And you're all 100% correct. That process of why Zion is no longer at sea level is called Uplift. So let's all celebrate together. Let's raise that roof. Whoop, whoop. Whoop, whoop. All right, so we have deposited our sediment. We have lithified it into a rock. We uplifted it high up out of the air, but it still doesn't look like those cliffs that we can see here today. At this point in our geologic journey, Zion is more like this cake right here. It's delicious, right? It's covered with this beautiful white frosting. But do you know what flavor cake this is? Do you know what is underneath this frosting? Please give me your best guess in that chat box as to what kind or what flavor of cake you think this might be. Ooh, vanilla. Vanilla, nice. Vanilla or chocolate. Ooh, I'm getting lots of vanillas. Ooh, vanilla and cream, yummy. Chocolate, yeah, it could be. A normal cake, yeah, it could definitely be just a normal cake. Ooh, a white chocolate cake. Yeah, it's making me hungry too. See, any other guesses as to what flavored cake this could be? What could be hiding under there? A rock, maybe? That'd be a little bit disappointing, right? You see this delicious looking cake, you try and take a slice out of it, and then it's just a rock. Might hurt your tooth. Yeah, so these are all really great guesses, right? It could be a chocolate cake, it could be a vanilla cake, it could be a rock cake, it could be white chocolate, red velvet. We don't know, right? It's covered with all of this frosting. In order to find out what flavor, what kind of cake this is, we need to cut it open. And when we do that, we see it's rainbow cake. Oh my gosh, none of you guessed rainbow cake. But we had no idea. It was completely coated with this frosting. We needed that knife in order to cut it open and reveal what was hiding underneath the earth or the frosting. And then was the same way. In order to reveal all of the beautiful layers that we can see today, we needed something to act like that knife and slice down our canyon walls. And you can actually see what has been doing that slicing for the last few million years right in the bottom of this picture. The Virgin River. The Virgin River has been weathering and eroding our canyon for about 2 million years. So we have reached our last step, which is weathering erosion, right? And we gotta break down and we gotta get down. So the Virgin River is an incredibly powerful force of erosion, which it means it picks up a lot of sediment and it moves it somewhere else. It's eroding it, so it picks up sediment and puts it down, deposits it in another place. But looking at this photo, that does not, to me at least, look like a very powerful force of erosion. How is it sliced down over 4,000 feet of cliff? Looks pretty shallow, slow moving. Well, it's not when the Virgin River looks like this that it is doing most of that eroding. Sometimes in the summer especially, this beautiful blue sky will suddenly turn dark. Lots of storm clouds will roll in. And then it starts to rain. And it rains, and it rains, and it rains, and it rains some more until this river goes from looking like this to looking like this. It's during a flash flooding event, the Virgin River will carry most of the 1 million tons of sediment out of our canyon, which it does every single year. The Virgin River removes about 1 million elephants of sediment from our canyon in every single year, in 1 year. And during the flash flood, the Virgin River, it will rise up to 10 feet and flow much, much, much faster than it does on a normal day. You might also notice the color of that water changed. Went from that really beautiful crystal clear to kind of like gross chocolate milk. Ugh. Why do you think the color of the water changed? In that chat box, please tell me what you think might have made this river become a chocolate milk river. Mud, it has sediment in it because of the sediment. Yep, dirt in the water. Rocks, dirt. Yeah, exactly. So it's all of the sediment and mud and dirt that the Virgin River is carrying and eroding away that has turned it this color. And during the flash flood, it's not just mud and sand, it's also boulders and trees the Virgin River can carry out of our canyon. It's more like a piece of sandpaper, slowly grinding and carving deeper and deeper and deeper into our canyon. But of course, weathering has also had a huge impact on what our canyon has been shaped as. So weathering is the breaking down of those rocks, turning them back into those tiny little sediments. So when I was asking you to kind of bump your fists together, I was asking you to weather your hands a little bit. I like to think of weathering as nature's hammer. And we mostly see weathering here in the process of freeze and thaw. Now, we are a desert, so it's really, really hot in the summer, but it's also really, really cold in the winter. It's not unusual for us to see frost, ice, and icicles. So freeze and thaw works in the way that when there is a crack in our sandstone, and as you can see, there are a lot of cracks, that water will trickle in. And then at night, when it gets really cold, that water will freeze. But water doesn't stay the same size as a liquid as it does in a solid. So what happens when water freezes? What happens to its size? What does it do? Awesome. Yeah, it gets bigger, it expands bigger. Yeah, definitely. So water expands when it freezes. And so when it gets bigger, it actually will push those two sides of the rock apart. And this process, it happens over and over. Maybe during the day, it gets warmer, and so this ice melts and trickles down deeper into the rock. At night, it freezes, it expands. In the day, it melts, goes deeper, freezes, expands, melts, goes deeper, freezes, expands, until it pushes both sides of these rocks further and further and further and further apart, and then boom, rockfall. Right? You can see this tiny little ranger standing in between these boulders looking up thinking, oh, I have so much work to do. Now, rockfall does happen every single day here in Zion National Park, but not always to this level. Sometimes those rocks might just be the size of my head or maybe just my fist, but they are constantly reshaping our canyon walls because all of this rock is falling off and then the Virgin River is eroding it out of our canyon. All right, my friends, so can you please tell me that which one of these is responsible for carving most of the canyon? Most of the canyon was carved by A, wind, B, rockfall, C, the river, or perhaps D, humans. All right, I'm getting a lot of C's so far. The river. I've got one B. Awesome job. And you're right. This is a little bit of a tricky one, right? But most of the canyon was carved or sliced down definitely by the Virgin River. Over the past 2 million years, it has been slowly working its way, carving out more and more of our canyon, revealing more and more of those layers. Now, rockfall, it is widening our canyon, making it a different shape, but it is the Virgin River that is slicing down deeper and deeper. Now, none of you said D, humans, and you are right. Us rangers, it's not part of our job to go out to the canyon and slowly whittle it away. Oh my gosh, wow, so we have just gone through the sedimentary rock cycle and carved a canyon together. Let's do all of those hand movements together one more time. Ready? So first, we deposited our sediment, right? We laid down all of our sediment to build up our layers. Then we lithified them into a rock. Ready? 1, 2, 3, lithification. Then we had a party. We raised the roof a little bit with Uplift. Let's see your best roof raising. Whoop, whoop. Whoop, whoop. Then we got down and we broke down and we carved a canyon. So let's see you get down and break down with our weathering and erosion. And this is the last time we're going to do it. So, maybe really get into it. Put a lot of shoulder action in there. Great job. So a lot of what we've been talking about has been focused on the past, right? We were talking about over 200 million of years ago. But how does geology impact us today? Do you think it does? Why do you think that we should care about geology right now and looking into the future? What do you think? Why do you think geology has an effect, or does it have an effect on us today? Yeah, we should care about the earth. That's a great thing, right? Geology tells us a whole lot about the earth. Yeah, the past looks into the future. That's another really great thing. So based on what has happened in the past, we might be able to piece together what might be happening in the future to this land. Yeah, definitely understands the earth. Geology impacts us a lot. Yeah, these are all really great answers. So we can use geology to look to see how natural disasters might affect us, right? If there's an earthquake that happens in the same place all of the time, then we might know that there's going to be an earthquake that is going to happen again there in the future. But geology actually impacts us every single second of almost every single day. We have to think about geology because we're using rocks all of the time. The roads that you drive on are made of rock. A lot of the minerals and things in your phone, that actually has to do with geology. And we especially have to think about geology when we're thinking about where to put a new building. Which brings me to my proposition for you all here today. So here in Zion, we are a very, very busy national park. We have about 4.5 million people coming to see us every single year. And we have one visitor center, this one right here. So if you come to visit us, which I hope you do, and you have a question for a ranger like me, you might have to wait in line to be able to talk to someone. So we've decided that it is time to build another visitor center. So I have two options for you, and I'd like you to tell me what you think of them, whether they be good or bad places to build, based on what we've talked about today and the information I've given you. So let's see my first option. Now this would be at the confluence or meeting place of both the Virgin River and Pine Creek. Now, because we're so close to so much water, when you're outside of the visitor center, you can hear both the river and the creek rushing by, and it's really calming. And that water provides a really important source of nutrients for all of the plants that are growing around there. So there's a lot of plant life, which attracts birds and things like that. So you get to see some wildlife there as well. Now, the ground that we would be building on is sand and gravel. So in that chat box, I'd like you to tell me whether this is a good idea, a bad idea, and why, reflecting on what you've learned already today about Thaw. Would this be a good or a bad place to build, and why? Ooh, I'm getting some really great answers. Yeah. So there are a lot of really good thoughts being brought up. Thinking about, ooh, I'm getting a lot of maybe not great idea. Yeah, thinking about the ground that we're going to be building on, thinking about where we're going to be building. All right, I'll give everyone about 5 more seconds. All right, so my answers in the chat box are overwhelmingly no. This would not be a good place to build for a lot of the reasons that you brought up, right? So most of you are saying, what are you talking about? We just saw that terrible photo of flash floods. And yes, so flash flooding is something we really have to think about. Now, these are just pictures of Pine Creek, not even the Virgin River. So if we put our visitor center at that meeting place, that confluence of not just one water source that floods, but 2, ooh, I don't think our visitor center would be around for very long. Now, some of you also brought up the great point of what are you building on? Sand and gravel? That's going to be eroded so easily. And you're right. So not only would our new visitor center be hit with this wall of water, the ground underneath it would be washed away. Both of those are sediments that will be eroded really quickly and really easily. So not many people would be able to enjoy our beautiful visitor center before it was destroyed. All right, let's take a look at my second option. Now this is on the east side of our park, out of that main canyon. We're surrounded by lower rock formations and near a really famous one, which is this right here, and that's called Checkerboard Mesa. I'm thinking that we build a little bit further out from the base of those cliffs, probably around right here. And this really flat sandstone area, I think would be perfect for parking. So in that chat box, could you please tell me whether you think this would be a good idea, a bad idea, and why? All right. Awesome. Okay, I'm getting some really interesting ideas. So thank you all. Awesome. All right, I'll give everyone about, again, 5 more seconds to speak now or forever hold your peace. Yeah, so I'm getting more mixed results on this one. I'm getting some yes and some ooh, no, I don't know. And some are saying yes and no, which is actually completely correct. So we think that this is probably the better place to build a new visitor center. But there is nowhere that is 100% safety guaranteed for a lot of the reasons that you all brought up in the chat box. So most folks were talking about that rock fall, right? I said that happens every single day here in Zion, and it does. But there are some steps that we can take to make sure that the damage wouldn't be as extreme. So building from out from the base of these lower or shorter rock formations would help a lot when there is a rock fall. Those rocks might just kind of stop right over here and not have too much damage on our visitor center, right? And you brought up the point, right? We're out of that main canyon, so we're not by the river. We don't have to worry quite as much about erosion and things like that or the flash flooding. But again, there isn't anywhere that is going to be 100% the best option, which is why we really have to keep thinking about this geology and understand that geology is happening every single day and will continue to happen for the next 200 million years, shaping and reshaping our canyon until who knows what Zion's going to look like next. All right, my friends, thank you so much for learning about geology in Zion National Park with me today. I really hope that after school or when you have time and it's not too cold, you can maybe go outside and try and explore the geology right outside of your home and look at some of those rocks and try and piece together your own geologic story of right where you are. I did promise to answer any questions that you might have. So if you are curious about something we talked about Zion, about being a ranger, I would love to answer anything I can.
We do have a couple of questions from YouTube. Can we start there?
Yeah, I'd love to.
The first one is, do you have a favorite part of the park?
Ooh, you know, that's really hard. And it's all so beautiful. So I'm really lucky that I actually live inside of the park. So I get to explore all of the time. But I think that one of my favorite trails is called the Perouse Trail. And it goes right by the Virgin River. And so when you're walking on it, you can hear the river flowing by. It's really beautiful. And it's incredible for kind of that golden hour right before sunset. Just all of the cliffs around us just light up like nobody's business. Honestly, it's kind of frustrating that the canyon just shows off all of the time. But I think that pretty much anywhere you go in Zion, you are not going to be disappointed.
All right, in the chat, why did you decide to become a ranger? Where did you go to school and for how long?
Yeah, those are all really great questions. So when I was younger, when I was a kid, I absolutely loved being outside. Any opportunity that I had, I was looking under rocks, rolling in the dirt, really just trying to explore the kind of natural world around me as much as possible. And I realized I didn't want to stop doing that when I became an adult. And I was really lucky to find this job here in Zion that allows me to continue to run around and look under rocks for bugs, as well as teach students and young people and visitors about something that I love really, really, really dearly. So I did go to school, I did go to college, and I actually studied anthropology and linguistics, but in California. So, but there are so many different ranger jobs that pretty much anything you might be interested in, you can study that and find a job as a ranger. And you don't even have to go to college. If you go to a trade school or do an apprenticeship and you really want to work on trail maintenance, so building trails, or even helping us with our roads and things like that, that's also an option.
I grouped these two questions together. One's in the Q&A and one's in the chat. It says, is it easy to find the fossils? And then a follow-up to that is, what is the coolest fossil you have found? And which canyons do you enjoy besides Zion?
Yeah, definitely. So fossils are pretty hard to find. I personally have not really found a fossil. A lot of the times they might be buried deep in those layers, and just the way that the rock or the sediment has eroded, we might not be able to see it until enough erosion happens to reveal that fossil. So some fossils are really, really hard to find, but we are lucky that a little bit lower elevation from us, actually outside of the park, there are lots and lots of fossils. There's actually an entire museum based on all of the fossils that you're able to find in the Kayenta layer. So it's there that you'll be able to see those skin prints, which I think is actually the coolest fossil that I've seen. It's not very often that you can actually look at what a dinosaur's scales have looked like. And you can also find things like claw tracks from when a dinosaur was running around, maybe swimming, and dragged its claws across the bottom of a lake, and that became a fossil. So there are lots and lots and lots of interesting fossils that you can see. Which canyons do I enjoy besides Zion? Oh my gosh, well, there are so many incredible canyons. Actually, you know, kind of southwest where I am, we have so many beautiful national parks. So right near me is also the Grand Canyon. Bryce Canyon is just a few hours away. Canyon Lands, Grand Escalante is a kind of a national monument, and that has a lot and lot of different canyons. Now, of course, you know, whenever you're exploring out in the desert, you always have to be aware and be safe as much as possible. So that means bringing a whole lot of water, and especially bringing a map so you know where you're going to be going.
I'm not sure if you want me to read these to you. I know you can see them. Do you want me to go ahead and read? Okay. What did you most like about being outside? Or what do you?
Gosh. Yeah, I mean, honestly, everything, except for the weather. I don't really like being outside when it's too rainy, too snowy, or too windy. But my coworkers make fun of me saying that I'm a little bit of a Goldilocks. So, but I do love being outside and being able to see all of these incredible landscapes. And I think that it really motivates and inspires me to keep learning about this park. Every time that I'm out exploring, I see something that makes me wonder, why is that the way it is? And so just, it really encourages me to keep learning about this beautiful place. I also think that it's really good for my personal mental health. If I'm ever feeling stressed and, you know, there's a lot of stressful things happening at the moment, just being able to go outside and kind of take a break from that has always been really, really important to me. And it's so fun to see the critters that are running around. So sometimes you can see things like sheep or lizards or snakes, and that's always a lot of fun, as long as you give them enough space and respect them, which is what we all need to do because we're visiting their home.
So that's a perfect segue. This is a three-part question. They're wanting to know what kinds of animals are in the park, and you've listed some.
Yeah.
Of those animals, are there any animal, plant, or land form that you personally would love to protect? And then do you have a favorite animal?
Ooh, okay, so we have so many plants and animals that live in Zion. We have actually over 360 different species or different kinds of vertebrates. So things with backbones, think amphibians, reptiles, birds, mammals, plus thousands, countless of invertebrates. So things like insects and snails and other things like that. So we need to make sure that Zion stays safe because it's a hugely important place for a lot of these animals to be protected and feel safe. Now, a lot of these animals are also threatened or endangered, so they can't live anywhere else. A favorite favorite land form that or animal that I would like to protect / favorite animal. Let's see. So thinking about those threatened species, we have a very special type of owl called a Mexican spotted owl. And that is a federally threatened species. And so there aren't too many of them flying around the United States. So it's really important that we're able to protect Zion because Mexican spotted owls love it here. They love to be up in our canyons where it's a little bit cooler and they can escape from the sun. So I think learning more about the Mexican spotted owl, and especially if I'm lucky enough to see one, that just really motivates me and really emphasizes the fact that it's so important to be able to protect this place. Now, favorite animal, I would say definitely Mexican spotted owl, but I also do love the more creepy crawlies that live here in Zion. Things like our tarantulas. So we do have tarantulas, like this one right here. And now these are really big spiders. But while a lot of people are afraid of them, they're not out to hurt people. In fact, a tarantula, its mouth is too small to even bite you. Still, you do not want to go picking one up. They are covered with this fur that is actually really itchy if it comes off in your hand. And that's a defense mechanism of our tarantula. There's a gray fox or a coyote maybe sniffing around, getting too close. Those hairs will actually get stuck in its nose, in its eyes of our coyote or gray fox, and that's really uncomfortable. And that tarantula doesn't look so much like a tasty treat anymore.
Very cool. Well, our time's ended, but would you mind telling people if teachers, students, parents watching this, if they would like to interact with you more, because you're amazing. In fact, you're in our teacher workshop and now I'm very nervous. You are 3G, you're 3D, you're NGSS, you get it all. It was beautiful. How do people find you if they'd like to explore having you for their classroom?
Yeah, definitely. And of course, we want to share Zion and talk to as many students as we can. So if you go to our website, which is the nps.gov site, so I think it's nps.gov/Zion, and you go to our distance learning page, or if you really probably just Google Zion distance learning, then you can see all of the other programs that we offer, and you can get our email address and shoot us an email, and we'll do our best to try and schedule as many as we can.
Well, you're so fun and amazing. And I have so many other questions I would love to ask you because that was really great. And thank you so much for being part of the National Biodiversity Teach-In. We appreciate you. And I'm sorry we have to go to our next one or I'd keep you. I'm sure you have something else to do as well. Thank you so much, Elsie, Ranger Elsie. And hopefully we'll see you next time.
Yes, fingers crossed. And it's been so lovely to chat with all of you. And I hope to see you all in Zion very, very soon.
Thank you.
Bye, everyone. Have a lovely day.
Bye.